Hello, welcome to RC Video Reviews. In today's video, I'm going to do a deep dive on the Hobbyeagle A3 Super 4, and I'm going to show you how to configure this gyro to work with ExpressLRS via CRSF protocol on your airplane. Now, before we get started, I'm going to set out some prerequisites. And the reason I'm going to do this is because so many times in these types of videos, people will come in and say, well, I don't know how to do this and I don't know how to do that. And you skipped over it. The problem is that you have to have a start and stop point on these videos or nobody will watch them. So I'm going to give some prerequisites and some links in the description for videos that I've produced that will take care of these prerequisites for you. Prerequisite number one, you have to have an ExpressLRS transmitter and receiver with ExpressLRS 3.0 or higher. I'll have a link in the description showing you how to do that. You also need to download the ExpressLRS Lua script and install that on your radio. The next thing you'll need to understand is how to configure your ExpressLRS receiver via Wi-Fi. I'll have a link in the description to show you how to do that as well. That's a standalone video. Next up, you'll need to install the Hobbyeagle A3 Super 4 Gyro configurator software that's called the A3 configurator and the USB driver. I will show you how to do that in this video because this video is focused on the gyro. So I'll show you how to download the software and the driver and how to install them before we get into actually configuring the gyro. Very important to be able to connect to the computer. Regarding the A3 configurator software, you're going to need version 1.2.3 or higher. The reason you need version 1.2.3 or higher is because that's when Hobbyeagle introduced CRSF as a protocol option in the configurator. The last prerequisite is that you'll need EdgeTX version 2.8.4 or higher. I'll be showing this example on a color screen radio, but don't worry, there's nothing proprietary about the configuration on color screen radios. So if you have a black and white radio like a Boxer or a Zorro, you can easily translate what I'm going to show you onto your black and white radio. Okay, with the prerequisites out of the way, let's get into the setup. And the first thing that I'm going to do is we're going to take a look at the radio configuration and we're going to start with the receiver. So all I've got here is a 5-volt power supply on my bench power supply, and I'm going to connect that to the receiver and bring it up in Wi-Fi mode. So I'm just going to connect and we'll wait for the green light to start rapidly flashing, and when it does that, we'll be in Wi-Fi mode and we'll go over to the web browser and take a look at the configuration on the receiver. But first, for you electronics gurus and tinkerers out there, check out PCBWay.com. PCBWay has a full suite of services available to make your ideas a reality, including PCB manufacturing and assembly, CNC machining, 3D printing, and injection molding. When you're ready to order, PCBWay provides instant quotes, real-time production tracking, and you can order as few as 5 boards at a time, which is great for early-stage projects. If you need an experienced partner to help bring your ideas to life, check out PCBWay.com. I have a link in the description if you'd like to give them a look. My receiver is now connected to my home Wi-Fi. I also want to mention this will work with any PWM-based ExpressLRS receiver. I happen to be using a Happy Model EPW6, but this will work with any ExpressLRS PWM receiver. Here is the web interface of my receiver, and I'm going to navigate over to the Model tab and scroll down. And the first thing I'll show you is that you need to set the serial TX option on channel 2. So if you look at channel 2, normally it comes out of the box at 50 Hertz, but we want to set it to a serial output. So we'll set ours to serial TX. And notice when you do that, it automatically grays out channels 2 and 3. There's nothing you can do about it, just let it happen. The next thing we'll do is scroll down to the serial protocol and make sure that is on CRSF. This will also work with S-Bus, but I thought I'd show how it works with CRSF because that's relatively new to the Hobbyeagle and not everybody necessarily knows about that. So it does work with CRSF. We just want to make sure we set the CRSF protocol. Now what this means is that we will get CRSF out of the receiver on pin number 2. The next thing we need to do is we're going to do a little bit of a remap. And the reason we're going to do a remap is because in ExpressLRS, they reserve channel 5 for arming, but we don't want to give up the channel 5 pin on the receiver. So the way we avoid that is by conducting a simple remap. You can see on my pin number 5 right here, output number 5, I have it set to respond on channel 6 from the transmitter. And all this means is that in my transmitter on the mix line, channel 6 will be output on pin number 5. That's all it means. And because I put channel 6 on pin 5, I went ahead and moved channel 7 to pin 6. That way they're in order. So I have channels 1, 2, 3, and 4 on the first 4 pins, and then on pins 5 and 6, I have 6 and 7. That's all it means. You can do your remaps however you want to do them. I'm just showing you the way it works for me. Pick whatever remap strategy that makes you happy. Once you've made these changes on your receiver, scroll down to the bottom and hit save. Once your configuration has been updated, you can disconnect your receiver from power, and now we'll move over to the transmitter. To wrap up the RF section of this configuration, the first thing we'll do is press the system button and load up the ExpressLRS Lua so we can take a look at how I have the transmitter configured for this example. I have my packet rate set at 100 Hertz. The telemetry ratio at standard, which is 1 to 32 when using 100 Hertz. And I've got my switch mode set at 16 divided by 2, which means we have a 50 Hertz packet rate between the transmitter and receiver. That works nice with the analog servos that I'm using, which are also 50 Hertz. That'll be the PWM output duty cycle between the Hobbyeagle A3S4 and the servos. So I have a 50 Hertz chain all the way through. The rest of the configuration is up to you. The main thing I needed to show you in the ExpressLRS Lua is that I'm using a 16 channel rate divided by 2. We can back out of the Lua script now and we'll take a look at the model settings. From the main screen, we'll press the model button and we'll scroll down, and the first thing I'll show you is that I've got an external RF set. The mode is CRSF. I have a baud rate set at 400K and the channel range 1 to 16. Your timer settings, your model name and image, that stuff isn't really relevant to this configuration, so I'll leave you to your own devices there. The next thing I will show you are the inputs. I've got high rates at 100 and low rates at 40 on the aileron, high rates of 30 and low of 20 on the elevator, no rates for the throttle, no rates for the rudder, and I do have a flap input defined. I'll show you that in just a little while on the model. On the inputs page, I've got channel 1 assigned to my port aileron, channel 2 assigned to my elevator, channel 3 assigned to my rudder, channel 4 assigned to my starboard aileron, channel 5 assigned to my arm switch, channel 6 and channel 7 assigned to flaps. You might say, why don't you have flaps on a Y cable? And the answer is because my mechanical setup on my model requires 2 channels for flaps. Obviously, there are ways to set these up on Y cables, but my particular physical configuration precludes the use of a Y cable. Notice there is no throttle configuration on this one because it's a desktop setup. You could also use a throttle pass-through on the A3S4 as an aux line, but since I don't have a motor on this one, I'm not including the throttle in my configuration. That's about it. You don't need anything else done in outputs, special functions, or logical switches to make this work. So now we've covered the ExpressLRS configuration on the receiver and the transmitter, and we've covered the radio configuration that will allow the model to work. Next up is wiring. I'll show you how to connect the receiver to the gyro and the gyro to the plane. There are a lot of pins on this Hobbyeagle A3S4. We're going to focus on the one that says serial RX/M and everything below that. And the reason we're going to do that is because we're going to use a serial connection between our receiver and the gyro. I like these setups because you only need one wire to connect your gyro and your receiver. Now, if you remember in the ExpressLRS webpage for this receiver, we set pin number 2 to be the serial output. So this is pin number 2. Pin number 1 is here, pin number 2 is here. Remember, pin number 3 is grayed out, so we can't really use that one other than for, say, power. If you wanted to bring power in on pin 3, you can do that. All right, so that's the wiring between the receiver and the Hobbyeagle. That's it. That's all you need. One single wire between pin number 2 on your receiver and the serial interface on the gyro. The next thing we'll do is connect the gyro and receiver to our model. And speaking of the model, this is called the RCVR2. I sell these in my Etsy store if you'd like to get one for yourself. It's a laser cut plywood sheet. There is no hardware included. I don't include servos, quick connectors, or the push rods, but I do have links in the description for where you can buy these on Amazon for the kit that I used. On my Etsy store, I sell just the model itself, just the board, no hardware. All I can say about these models is they are very useful on the desktop for experimenting with things like gyros because it's a lot easier to manipulate this than a great big airplane when you're trying to figure out what's going on with your gyro. So what happens with the gyro is that we're inserting it between the receiver and the model, right? So we have our receiver and that provides the input from the radio on this wire. Then the gyro is going to do things depending on how you have it set up, and then it's going to output on the PWM leads going to your model. So we'll look at outputs number 1, 2, 3, and 4 for this example. I'll start out by connecting my port aileron to pin number 1 because that's what's in my model configuration. All right, there's port aileron. We put that on output number 1. Then I'm looking for my elevator, and this is why I label these. Makes this job a lot easier. And we'll connect that to output number 2. Then I'm looking for my rudder, which will be on output number 3. And remember, these channels match what I have in my mixer. They don't have to, and that's one of the things I really like about the Hobbyeagle is you have a lot of flexibility in terms of mapping your outputs to your radio. Okay, so for channel number 4, we have our starboard aileron. The last thing we'll do is connect the flaps, and we're going to connect the flaps directly to the PWM signal because we don't need a gyro to interfere or gyro stabilize our flaps. So we're just going to connect it straight to PWM. And I also want to do this to prove a point, and that's to show you can have outputs in a serial stream and via PWM simultaneously. The first thing we'll do is connect the port flap, and that's going to go on pin number 5, which don't forget we remapped in the receiver UI to channel number 6. So pin number 5, 1, 2, 3, 4, 5, that gets port flap. And then for pin number 6, I'll connect the starboard flap. And don't forget in the UI, we remapped output pin number 6 to channel 7 from the radio. So 2 PWM outputs on the receiver that go to flaps and 1 serial CRSF output that goes to the gyro. So that's it for the wiring. That's all you really need to see on the wiring. Before we can configure the gyro with our computer, we're going to need to download the A3 configurator software and a USB driver. Inside the box, you should get this little adapter that plugs USB into your computer, and then this end goes into the gyro. But before this works, we need to install a driver. I'll have a link in the description for the A3 configurator download page. You want to find the section that says Install USB driver before operating the config utility. Click on that link and download the driver. And then after you've done that, click on the download button for version 1.2.3 of the configurator. If you're a Mac user, don't know what to tell you. You're going to have to get access to a Windows computer. I do not believe they have a Mac or Linux version of this configurator. Both of these downloads are now on my desktop. I'll start with the driver first. We're going to right click on this and hit extract all, and I'll just extract it to my desktop. So that makes a nice folder with the CP2110X Universal Windows driver. We'll click on that and then we'll run the installer. You'll have to pick the right installer for your system. In my case, I'm running a 64-bit version of Windows, so I will run that installer. We'll click next and then finish. And that's all you need to do to install the driver. Yours might look a little different than mine because I already had the driver installed. So if it looks a little different, that's okay. Just allow it to happen. Click next, 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 install, and let it happen. The next thing we'll do is install the A3 configurator itself. Go ahead and click on the installer and then click on the next button. Choose the location where you want it. I like to install it for everybody that uses my computer, which means just me. And then after the install is complete, you'll be left with a configurator icon right there on your desktop. The next thing we'll do is connect the micro USB side of the USB cable into the data port on the front of the gyro, and then we'll connect the other end to our computer. Once you do that, you should hear that USB bong on your computer, and then we can open up the A3 configurator software, and you should see, if everything worked right here along the bottom, COM4 connected. Now, yours might say COM5 or COM3 or COM10, it doesn't matter. As long as you see one that says it is connected, that's what we're looking for. In my case, I'm COM4, and there is the Silicon Labs CP2110 USB to UART bridge. That's how you know you have a successful install. The next thing we'll do is update the firmware on the A3 itself. We'll do that by clicking Firmware Update, and then in the drop-down list, you want to select A3 Super 4. And then for version, make sure you select A3 Super 4 version 1.6. It was released June 13, 2023. This is the one that gives you CRSF. Go ahead and click that, and then hit start. If your update works correctly, you'll see this green status bar floating by on the bottom of the screen. Just let the software finish its job. When the firmware is updated successfully, you get a little dialog box, click OK, and then when you're done with the update, click on this close button. And that brings you back to the main interface for the configurator. Finally, we can hit connect. And once you hit connect, that brings you into the configurator itself, and that lets us go through and make changes to our A3 Super 4. You'll see some options on the screen that are not standard. That's because I've been fiddling around with my A3 Super 4. So don't worry if what you see on the screen doesn't match yours exactly. It's fine. It's no problem. All right, to move around in the configurator software, there are some tabs along the top. So we have basic, that's where I am now. We can click on wing type, mount orientation, receiver, outputs and servos, sensor, and advanced. Let's go through them one by one. We'll start with basic, and we're going to talk first about the mode switch. One of the cool things about the A3 Super 4 is they give you an option to enable a 6-position flight mode. So if you put a check mark in here, that means you can configure your radio to use 6 positions. So like a 6-position switch on a TX16S, for example, that might work. And in position number 1, you can define what you want it to do. In my case, I like position number 1 to be off. Position number 2, you can define for normal, lock, angle. I'll cover all these modes in a minute, but you can pick anything that you want. In my case, I like normal for position number 2. And then for position number 3, you can also make choices. And you can do that all the way through 6 position. Now, because I really have no intention of using 6 different modes on my gyro while I'm flying, I'm going to turn this off, but it's there if you want to use it. The next section is what we call user mode. And what user mode allows you to do is set what happens in your user-defined mode to the aileron, elevator, and rudder. So for example, let's just say I wanted a mode where I could use it to land the plane. In landing the plane, I want my ailerons to be held level because really, you don't want to be messing around with the ailerons too much on final anyway, right? So leave your ailerons level. And all that means is auto level. So you can still move them, but if you let go of the aileron stick, it'll maintain level for you, okay? And then in the elevator, I really don't want the gyro fiddling with that too much while I'm trying to land, so I'll leave that in normal mode. And what that does is it reacts to uncommanded movements like wind. It's basically stabilize mode. So if there's a wind gust, the gyro will react to it, but it doesn't try and do auto level. It simply reacts to uncommanded movements. And then in the third section for rudder, you can turn that off. Let's say you don't want the gyro interfering with that at all. So in this mode, our ailerons are held level, our elevator reacts to uncommanded movements, and our rudder is turned off. The gyro doesn't touch it. The next section is called maximum angle, and you see roll and pitch here. And what this does is it limits the bank angle possible of the model in both the roll and pitch axis when you have angle mode selected. So for example, if you don't ever want the airplane to go over 30 degrees in roll or pitch, you'd set these values to 30. If you want them to be, say, no higher than, say, 60 degrees on roll and maybe 40 degrees on pitch, you can do that as well. And the gyro will not allow the model, when it's in angle mode, to exceed that degree of roll or pitch. Before you start working on your gyro, you want to make sure your control surfaces respond correctly to your radios. So before you start monkeying around with any of these settings, make sure your radio is moving your control surfaces correctly in the first place. If you don't do that, everything else is going to be a train wreck. So we'll do a quick little test. I'm going to bank to the right, which means my right aileron should come up, and it does. I'll bank to the left, which means my left aileron should come up, and it does. I'm going to pull my elevator down, which means my elevator should come up, and it does. I'll push my elevator forward, which means the elevator should go down, and it does. I'll add right rudder, so the rudder should move to the right, and it does. I'll add left rudder. That means the rudder comes to the left, and it does. So the control surfaces now are correct. And if you need to make changes, by the way, you do that in your model settings. You can go into your outputs, for example, and if your elevator was going the wrong direction, you can reverse it. You can say, let's invert that, and now the elevator is working backwards, right? I inverted it from what I had. You just need to make sure it's working correctly using the tools available on your radio. Once you've done that, we can go back to the gyro and make sure the gyro is doing things correctly. So I'll put it into level mode, And now what I'll do is I'm going to roll the gyro. Remember, we can roll the gyro. We don't have to move the model because the sensor is inside the gyro. So if I simulate the aircraft rolling to the left, that means the right side of the gyro goes up and the left side would probably go down. And you can see what's happening here. The gyro is saying, hey, wait a minute, we're supposed to be level. So let's give a little right aileron up to have us come back to level, and it will keep that until the gyro is back at level. Does that make sense? Now, if the gyro is not moving that surface in the correct direction, that's what these reverses are for. So let's say the ailerons were flipped. Right now, mine are checked. So I'm going to uncheck these two. We'll uncheck aileron 1 and aileron 2, and we're going to hit right. Don't forget to right. You have to hit right and then write it to the controller. Then after you've done that, now what should happen is my ailerons should be gyro stabilized inverted. So if I roll to the left aileron comes up. That's bad. That's going to increase your roll to the left. All right, so that's backwards. If that's not correct, this is where you fix it. You go into the reverse section on the gyro setting and reverse those controls so they work correctly. So we'll hit right again. And after we've done that, I'm going to pitch to the left one more time. The right aileron should come up. Okay, there's my right aileron that comes up, so that's correct. And you want to do that with all of your axes of control in level mode. So if I pitch the model up, we should see that elevator go down, and it does. Now if I pitch the model down, that elevator should come up, and it does. That's what we want to see. And this gyro reverse section is where you invert the controls if something's not right from the gyro output. The next section we're going to talk about is gain, and I'm going to bring the manual up for that because gain gets a lot of play. A lot of people ask questions about gain, so let's just read the manual and see what the manual says about it. It says the A3 Super 4 provides separate adjustment of basic gain on the aileron, elevator, and rudder. Basic gain determines the reaction strength of the gyros. So what they're saying is how much does the gyro react to perturbances, whatever they are. In general, the higher the gain, the harder the airplane will stop after a rotation and the more precise the airplane will fly. However, if you set the gain too high, that can cause oscillations. You don't want to slam the airplane to a stop. You just want it to be enough. So gain is one of those important things that if it's not set right, it'll cause oscillations and bad behavior. So if your gain is too high, the airplane will tend to oscillate at high frequency on the axis in which you have it set too high. And conversely, if you set your gain to 0, that effectively disables the gyro, which is actually kind of a cool little trick. So instead of eating a switch position, you can set your off position to be normal and then set your gain down to 0 with the knob, and that effectively turns it off. And then once you start dialing in a little bit of gain, it just kind of acts against the wind and gives you a little bit of stabilization with just by adding a little gain on your S2 knob. Hobbyeagle recommends starting with a low basic gain of about 30%, switch to normal mode, and check it out. See what happens. If you need to make adjustments, you can do that if you've set up Remote Master Gain. I can't stress enough how important it is to spend a little bit of time working on your gain. It is somewhat model dependent, somewhat control surface dependent, size of the model dependent. So just take a little bit of time. It's worth it if you invest a little time working on your gain. And don't forget, you can do it with a Remote Master Gain on your radio. Mode gain seems to work in conjunction with the basic master gains. So if you turn the remote master gain down to 0, the mode gain doesn't have any impact at all. It's 0. So the basic gain, if it's set to 0, the gyro effectively is off. If it's not set to 0, based on my experimentation, it looks like these mode gains basically act like multipliers. They slightly increase or decrease the basic gain depending on the mode that you're in. The last thing to talk about is the remote master gain. Again, I have mine set on channel 9 and connected to S2. You can also use a 3-position switch if you want, which will probably give you something like 0, 50, and 100. And the remote master gain will always default to 100 if you do not connect the channel. I don't recommend doing that. I highly advise you to connect that remote master gain. That way you can make adjustments while you fly and if the conditions change. All right, with gain out of the way, let's get back into the configuration and we'll take a look at what we've got here. It's probably a good idea to start with your basic gain around 30% like Hobbyeagle recommends, and if that's not enough, you can always add more. So just set your gains to 30%, and don't forget you can also manipulate these with your remote master gain. Don't forget to write your parameters to the Hobbyeagle after you change them. All right, my base configuration has the basic gain set at 30% for the aileron, elevator, and rudder. And if you notice on the screen, my remote master gain is set to 0. So that effectively shuts down the gyro. And I'll prove that by showing you that we're currently in level mode. And if I move the gyro around on the table, nothing happens. The control surfaces don't do a thing. Now, if I start bringing that remote master gain up, and let's say we'll set it at 50%, thereabouts, and I start moving the gyro, you can see the control surface is starting to move in level mode. Now the movement's kind of small because I have the basic gain set at 30. So if I really want to get the maximum gain up to 30%, I turn the remote master gain up to 100%. And now as I move the gyro, you can see the control surface is moving just a little bit more. Okay, so remote master gain impacts the basic gain for the aileron, elevator, and rudder simultaneously. Next, let's talk about the different flight modes on the A3 Super 4. Position number 2 is currently set to normal, and you can see I'm on normal down here in the status bar. And what that means is it reacts to uncommanded movement. So with my gain turned all the way up, if I get a gust of wind, for example, what will happen is the gyro will react to that gust of wind, but it won't stay. So as the wind blows and the airplane moves, you can see when I move that gyro, the surface reacts, but then it goes back to neutral. That's called stabilized mode, and really what's going on is it's reacting to uncommanded movements. A wind burst is a good example of an uncommanded movement. The wind blows, perturbs the plane, the gyro says, hey, I'm perturbed, it makes a reaction, and then the control surface goes back to its default position. That's normal mode. As you can see, there is no specific gain setting for normal mode. That basically falls under basic gain. Next up is lock mode. This one's really interesting. We'll write this configuration, and now you can see we're in lock mode right here on the status bar. And what this one does is as you move the stick, let's just do an example. I'm going to do a bank to the right. So that means the right aileron should come up. So there's my aileron. And now as that aileron comes up, the gyro is going to roll inside the plane. Okay, so we're going to roll it, roll it, roll it. And I'm going to stand it up and say it's 90 degrees. All right, so the gyro is now 90 degrees. If I let go of that stick, notice what happens. With the gyro at 90 degrees, it put the ailerons at center. So what it's doing is locking your position. If the plane tries to reestablish itself at level, you can see the gyro is making a correction. As I flatten the gyro out, it's saying, no, let's go back up to that knife edge that we were just in. So if we go back up to knife edge, there we are. It's back to level on the ailerons. The idea behind this one is, say for example, you want to fly a knife edge. You can put it in lock mode, enter the knife edge, let go of the sticks, and the gyro holds the knife edge for you. That's what's going on. And then to break that knife edge, all you have to do is move the sticks. So once you move the sticks again, they go back to neutral. All right, the idea behind lock then is that you put the airplane in a certain attitude, and when you let go of the sticks, the gyro maintains that attitude for you. That's lock. Earlier in the video, I said I believe that the lock, angle, and level gains are multipliers on top of basic gain. Let me show you what that means. If I set my lock gain on the ailerons all the way up to 100 and write that out, and then I enter the aircraft into a roll, and the gyro rolls over onto its side. I let go of the sticks. Now the model is level. And as I set the gyro down flat again, you can see that the ailerons are trying to get back to that knife edge. All right, here's what happens if I turn down my remote master gain. If I turn that down to 0, you can see all of that control surface authority just went away. That's why I believe the lock, angle, and level gains are multipliers on top of the basic gain. All right, if I bring my remote master gain back up to say 100, and then I make that right turn again, the gyro gets moved over 90 degrees on its side. I let go of the sticks. The controls go back to center, but that means it's a knife edge. And as the gyro flattens back out, you can see it tries to manipulate the ailerons to go back in the knife edge. All right, that's lock mode. Next up is angle mode, and this is a nice one if you have a student. And remember, you have control over the maximum angle right here. I have the roll set to 60. I'm going to bring it down to 30, and I'm going to bring the pitch up to say 90. And then I'll hit right and save that. Okay, I'm in angle mode, so I'm going to do a bank to the right, pitch right, and as the gyro goes over, you can see all by itself, it's leveling the ailerons back to the neutral position. And as I go past the 30-degree mark, it's actually reversing the ailerons to force it to come back to 30 degrees. So there's about 30 degrees on the gyro, and the ailerons are centered. If I put the gyro flat on the table again, you can see my initial commanded movement on the aileron is still in effect. So that's the roll example. Now here's the pitch example. As I pull down on the elevator, you can see the elevator goes up. But as we increase past 90 degrees, you can see the gyro issuing a command to say, no, we're not allowed to go past 90, so let's come back down a little bit. To recap, angle mode limits the degrees of roll and pitch allowed by the model. All right, next up is level mode. This is the traditional auto level mode. So I'll write this configuration out, and all this is going to do is when the sticks are neutral, the control surfaces are neutral. That's it. So if I move my sticks to the right, and I move the gyro around on the roll axis, it doesn't really care. It doesn't really react much to that. But if I let go of the stick and the plane moves, you can see the control surface over here is going down. This one's coming up. It's trying to return itself to level. And that works on the elevator, the rudder, and the ailerons. So this is traditional auto level mode. That's level. And don't forget, you have the ability to manipulate level gain in relationship to the basic gain on the configurator. So if you feel like it's snapping a little too hard when it's doing auto level functions, you can bring the aileron axis down and you can bring the elevator axis down depending on what you see. Just don't forget to write your settings. Okay, that's auto level mode. Next up is hover mode. This one's actually kind of neat. I'm going to hit right on this one. And what hover does is exactly what it sounds like. It puts the airplane into a hover. So you can see I've got the gyro flat on the desk. And what I'm going to do is move it. And as I move it, you can hopefully see the elevator right now is pitching up. And it'll stay like that until the gyro is vertical. Once the gyro is vertical, it's returning the elevator to the middle or neutral position. It will also manipulate your ailerons to help keep it in place, and it manipulates your rudder. So as you tilt it right to left, which is in a hover, that's how you control tilt. It's with the rudder. It also manipulates your rudder. That's kind of a cheat mode for hovering, but if you want to try it out, that's one way you could impress your friends. That's hover mode. Back in the configurator, note they have hover gain for elevator and rudder, and I'm not sure why they exclude aileron because the ailerons are actually manipulated in hover mode, and they are kind of important to keep it from rolling if you don't want it to spin on the longitudinal axis of the aircraft. So not sure why they excluded that one. And the last mode is the user mode. This is the one we talked about earlier, where if you put this in user mode, what it allows you to do is configure what happens to each axis of control in user mode. So the example that I used is, let's say I want to use it for landing. I can set my ailerons to be in level mode. So you can see as the gyro pitches, the ailerons react in the opposite way until the gyro is flat again. That's level mode on the ailerons. And for the elevator, I have it set to normal, which means it'll move and react to a perturbance and then go back to neutral. So I'll pitch up and you can see movement, pitch down real quick and then back to neutral. I'll do a pitch down. We saw a pitch up real quick and then back to neutral. And then for the rudder, I just left that off. So in the user mode, you can configure where you want the gyro to react, what surfaces, and how you want them to react. Okay, that's everything you need to know on the basic tab. The rest of it's going to go a lot faster. For wing type, you have the ability to allow the gyro to do your mixing. Don't forget, if you use a gyro, what you're going to do on your radio is just set aileron on your port wing, elevator on your starboard wing, and the gyro will handle the mixing for you. I'm really not set up to show you that on the video today, but just pay attention to this fact. If you're using a gyro and you have a delta wing, all you do is set up aileron on one, elevator on the other, and the gyro will mix the rest for you, okay? And then the same thing with V-tail. If you got your elevator and rudder together, it will provide the mixing for you. The only thing you have to do is set the output function for the two tail servos to elevator and rudder. The gyro will take care of the rest for you. Mount orientation simply has to do with how you're going to put the gyro in the plane. The one thing I'll say is there's no option to reverse it to the best of my knowledge. You might be able to finagle your way through playing with the reverse on the gyro, but I wouldn't recommend it unless you really know what you're doing. But there is a mark on the gyro. It's a little arrow that always has to point forward, and your outputs always have to point aft. So just follow what's on the screen, and you can do face down, face up. You can have it upright on one side or upright on the other. So a couple of different options for mount orientation. And now the receiver. This is the important part for ExpressLRS. Under receiver type, you want to select serial digital receiver. And then for the protocol, you'll want to drop this list down and scroll all the way to the bottom for TBS/EDC. ELRS, CRSF. That's CRSF, okay? It's the same protocol on TBS and ELRS. So click on that and then hit write. And when you hit write and save that, if you're bound to your receiver and you've got your connection set correctly, when you move the sticks on your radio, you should see a corresponding output on this screen. If you don't see that, you may as well just stop and figure it out because nothing else is going to work. You got to make sure you see this. Okay, so here's output on my ailerons, my elevator, my rudder, and I don't have an elevator 2. That's why this is marked none. And then for my mode switch, that's on switch C. I'll move that and you can see my mode is moving. I'll spin my S2 knob. There's my gain. And then earlier in the video, I told you I would show you that you can have simultaneous serial stream output and PWM output. Now I'm going to prove it to you. In the Hobbyeagle, I have aux1 and aux2 set to listen on channels 6 and 7. So when I move my flaps, you can see that there are 6 and 7. They're moving. You can also see on the model these flap servos are moving. And remember, those flap servos are not connected to the gyro. They're connected to the PWM outputs on the ELRS receiver. So that proves you can see outputs inside a serial stream and on the PWM outputs simultaneously. I'll move it one more time just so you can see it happening. There's the CRSF stream showing channels 6 and 7, and you can see these moving, PWM. Those are connected to the PWM pins on the ExpressLRS receiver. All right, let me show you the radio configuration and how that maps up to channel numbers on the right-hand side. This is one of my favorite features of this radio because it gives the pilot all kinds of flexibility on how they map the radio outputs to the channels being monitored by the gyro. So in my case, on my radio, I have channel 1 for the port aileron. So on this aileron line, I have channel 1. So that maps my output in the serial stream of channel 1 to this line, the aileron. It tells the gyro, you are now connecting channel 1 to an aileron. My elevator is set on channel 2, and you can see that in my edge config right here. Channel 2 is elevator. Channel 3 is rudder. Channel 4 is my starboard aileron, so that's channel 4. Pretty basic so far, right? On elevator 2, I have no elevator 2, so it's set to none. Next, we're on our mode switch. So I have my mode switch set at SC, and I use a weight of -100 because I want my first position to be off or down. That's just the way I am. It doesn't really matter. You can do overrides, lots of different ways to correct this, but I like mine to be SC down, and that's the way I have it set up. So -100, just one switch, SC, and that is set on channel 8. So if I move my SC switch, you can see my mode moving on the output monitor right here. My gain is set on channel 9 on S2, and I have a value of 100. I just put a label in here that says gain, source is S2, weight is 100, and when I spin that S2 knob, you can see my gain go up and down. That's it for the receiver page. Next up is output and servos. This is very simple. This talks directly about the output configuration on the gyro that we covered in the very beginning of the video when I wired my servos to the gyro. Out 1 matches aileron 1. So you can see out 1 here is set to aileron. You could make it your elevator, your rudder, it doesn't matter. I like mine to be aileron. Oh, and by the way, if you don't want it to output anything, you can inhibit it by selecting INH. That means inhibit. So I'll leave mine on aileron. My output 2 goes to my elevator. Output 3 goes to my rudder. And output 4 goes to my second aileron. And notice on output 5, I have nothing. That's inhibited. I'm not using a 5th gyro manipulated output in this configuration. On the sensor page, you can see what the gyro sees by rolling it and pitching it. So if you look at the accelerometer section, you can see what the gyro is seeing. And then near the bottom, you have 2 options for level and hover calibration. So for example, once you've got your gyro mounted in the plane and you put it in auto level mode and it pitches up or down, you can come in here and try a calibration or an offset. I'll show you calibration first. Make sure you're on a very flat surface, push down if you have to, and hit level calibrate. It says, make sure you're on a flat surface horizontal to the ground and then hit OK. And then once you do that, it should complete the calibration and you should be at 0 on your roll and pitch axis. And then you can do the same thing for hover if it's out a little bit. If the calibration isn't getting you there, you can also enter offsets for roll and pitch in the level offset. And this is for auto level. So if you need to make an adjustment there, you can do that as well, just to fine tune for pitch and for roll. And you can do the same thing for hover, for yaw, and for pitch. Once you're done, don't forget to write your settings back to the controller. The last page has some advanced settings. Stick deadband of 5% is recommended for most radios. I've kind of tinkered with this a little bit and I can't really seem to find too much of a difference. The idea here is that some gimbals don't recenter perfectly. So if they don't and you need a little bit of deadband for the gyro, you can enter that here. For servo frequencies, analog servos, 50 hertz is great. If you've got digital servos, you can actually crank up the output of the servo frequency all the way up to 333, which is actually pretty cool. Now, gain level. The gain level is also referred to as the gain curve, and the best example that I can come up with to describe what's going on here is that this setting moves the entire gain curve up and down on the y-axis. So for example, with a gain level of small, I'm in level mode. If I roll my ailerons, you see a certain amount of movement on the aileron, right? Now, if I take that gain level and move it up to medium and then hit right, then we'll roll the gyro again, and you're going to see quite a bit more movement on that aileron. So the curve has been moved up on the curve graph on the y-axis. The whole thing moves up. The relationships don't change. The curve is just shifted up. And then if I set the gain level up to large and write that out, you'll see a fairly substantial movement when I move this gyro. So there's a pretty substantial movement and it happened quickly. So again, the gain level is a reference to the gain curve, and I believe it just shifts it up and down on the curve graph. The last option on this page is control behavior, and I've tried several different methods of coming up with a visual demonstration, and I can't really seem to get something that's satisfactory to me. So I'm just going to read to you what the book says. After you put the gyro in, you've effectively converted your model into a fly-by-wire system because you've inserted something to manipulate your controls between the actual controller and the wires that run the servo motors themselves. That is effectively a fly-by-wire system. So once you've installed a gyro, they're saying that the airplane will become a little less responsive because now you've got a PID loop in between your sticks and your airplane. So the idea is the control behavior allows you to reduce the strength of the gyro corrections when stick input is detected. Again, I couldn't really find a good way to demonstrate that one visually, so we just have to go with the book definition. Last up is the digital filter. On all my planes, I've stuck with 20. It seems to do just fine. If you've got a gasser or a nitro, you might want to lower it to something like 5. You don't want to get too crazy with this because it can cause heat buildup on your servos. So I can tell you that 20 hertz seems to work fine on all my electric planes. That wraps up my deep dive on the Hobbyeagle A3 Super 4. If you like this kind of content, make sure you smash that thumbs up button, subscribe, and hit the bell so you know when new videos hit the channel. YouTube should recommend another video for you right about now. That's all I've got for today. Take it easy and go fly something.